Okay, so I want to finish our discussion today by looking at Investigation 18 Part D, and this is one that you were not assigned to do in the homework, but I want to talk about this one because um, you may start to get the impression, based on your work on parts A, B, and C, that the formulas you come up with for figure n are always going to be linear, or in other words, that when you graph the when you graph this sort of growth pattern, you're always going to get a straight line, and that's not necessarily true. And part D shows this very well. So part D, I'm just going to kind of color these in so that otherwise it gets a little bit confusing what it is that we're looking at. Um, Again, this is more clear in the actual textbook. It's just because I'm working with a photocopy that for some reason it didn't color these in very well. But anyway, this is what part D looks like. Um, so let's see if we can come up with number sentences here for part D. And what I'm going to do is I'm going to take you through a few ways that that you might fail, right? A few ways that you might try to do this and not come up with anything that's really all that workable. Okay, so one of the things that you could do is you could notice, like, okay, so when I see this, this is a lot like part A, where it looks like you're just adding stuff around. Except that, well, okay, so let's say that we try to look at it that way. So we try to look at it like part A, where we think of it like, you know, that little figure, and then we've got that square again in figure 2, but we're also adding these things around it, okay? And then for figure 3, we've got the little tile in the middle, and then the ones that went around it. And then we're surrounding those with a few more tiles, right? So this is one way that you could potentially think about this growth pattern. Now if you try to write out a number sentence for that, then for figure 1 it's going to be, well, just 1. And for figure 2 it's going to be 1 plus 4, or maybe you could call it 2 times 2 or something like that. And then for figure 3 it's going to be 1 plus 4 plus 8. And now we run into a little bit of trouble, because what in the world is figure 4 going to look like? It's almost impossible. Well, it's not impossible to tell what it's going to look like, but what I mean is, what is the number sentence for figure 4 going to look like? Because we're not sure. We don't have really enough information just looking at the numbers. We don't have enough information to know if the next one is going to be 1 plus 4 plus 8 plus 16 maybe? Or is it going to be 1 plus 4 plus 8 plus 12? Right? Both of these could be true, right? If we're doubling the number each time, then it would go 4 and then 8 and then 16. If we're adding 4 each time, it's going 4 and then 8 and then 12, right? So we're not sure really, without drawing out the next figure, we're not really sure which one to go with. But that's not even the biggest problem. The biggest problem is this. Imagine writing out your number sentence for figure 100. Okay? That's going to be an issue, because you're going to have to, like, let's say that the correct pattern is the bottom one. You're going to have to say 1 plus 4 plus 8 plus 12 plus 16 plus 20 plus 20, and dot, 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 all the way up to, like, whatever it would be by the time you get to the 100th number in that particular sentence. So that's not very useful. We might be able to fix it up, and I might come back to this idea if we can kind of fix it up. Maybe before we move on, though, we should figure out what the next number should be. uh, whether it should be 16 or 12. Let's see. So if I'm just going to build figure 4 on top of figure 3. Whoops, sorry. So figure 4 must look something kind of like this, right? So how many have we added? We've added 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it should be 12, right? So it should be 12. But again, this is slightly problematic. I mean, we're not sure exactly where to um, uh, it's problematic in the sense that if you think about writing out this particular number pattern for figure 100, you're going to have to write out 100 numbers, which is not a very good way to try to solve this problem, I think. So, okay, so there's one attempt. What's something else we could try? Another thing we could try, maybe, would be to, let me fold this in half so that I can have everything on the page at once. Another thing we could try is we could try the trick that we did in like part B, where we looked at like all of the squares, but then just subtracted off what was missing, right? Subtracted off what was missing. So if we tried to do that for this one, that's okay. So looking at figure 2, it looks like we have a 3 by 3, and that we're missing 1, 2, 3, 4 squares. Maybe you could call it 2 times 2 or something. So it looks like we're missing so it looks like we have a 3 by 3. So it looks like we have a 3 by 3, but then we're missing a 2 by 2. Maybe something like that. Okay. Thinking about how I would express figure 1 in this way is a little challenging at this point. I mean, maybe it's like 1 by 1. Maybe it's like a 1 by 1 minus a 0 by 0. Right? So that could be, I guess. If we are following along with that pattern, then it seems like this one would be like a 1 by 1 and then a 3 by 3, so maybe the next one is like a 5 by 5. Except that it's not, right? Because we have 1, 2, 3, 4, 5. Oh, it is. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it is a 5 by 5. And then are we missing a 3 by 3? I mean, we've got 2, 4, 4, and 2 that we're missing. You know what I mean? We're missing 2, 4, 4, and 2. I guess you could borrow 1. And then you have 3, 3, 3, and 3. But see, then it's still not a 3 by 3, is it? It's a 3 by 4. So you have like a 5 by 5. So it's like you have a 5 by 5, but then you're missing a 3 by 4, which is odd, right? That's really weird. It's not matching up with the pattern that we kind of suspected. And it's not at all clear what the next figure is going to look like. Right? So here we went 1, 3, 5. So maybe you could say the next one is going to be 7, but then is it minus a 5 by 4, or is it minus a 5 by 5? I mean, it's hard to tell, right? So that's another kind of I would say failed attempt. I don't think it's beyond salvation. You might be able to fix it up somehow to get it to work, but it's not immediately clear to me how we fix that problem. I mean, I suppose if we go 4, 2, 0, maybe the next one's 6, but then maybe this was supposed to be a 1, and then it's 1, 2, 3, 4. Okay, so maybe you could say it's maybe 6 by 6 minus, I'm thinking 1, 2, 3, 4 by 0, 2, 4, 6, maybe. maybe, right? Maybe. I'd have to draw out figure 4 to see if this works. Well, I've actually done that in pencil. So figure 4 would be a 1, 2, 3, 4, 5, 6, 7. Wait, 1, 2, 3, 4, 5, 6, 7. Sorry, this was supposed to be a 7 by 7 because it's going 1, 3, 5, 7, right? Not a 6 by 6. So that lines up. 1, 2, 3, 4, 5, 6, 7. That's okay. And then, but am I subtracting off 24? I have 2, and then a 4, and then a 1, 2, 3, 4, 5, 6, and then a 1, 2, 3, 4, 5, 6, and then a 4, and then a 2. So, oh goodness, I mean, yeah, I can move this 2 up to this 4 and make it a 6. I can move this 2 up to this 4 and make it a 6. And then I've got 6, 6, 6, and 6. So it is a 4 by 6. So I think this is probably the correct pattern. But man, is that complicated. That's hard to figure out. I'm interested in coming back to this one. I'm interested actually in coming back to both of the ones that I've tried so far and trying to make them work. But I'll definitely say it's not the easiest way to go about it. So let me get a fresh one. I printed off another one because I knew I was going to try a bunch of things that didn't work. So let's try this a different way. So again, I'm just going to shade in like so that we're clear about how many tiles we have in each figure. Okay, so let's try this another way. So maybe another way I could do it is to just like do it in columns the way that I've done some of the previous ones. So like this one would just be, right, so like this one would just be 1, right? And this one would be 2 plus 1 plus 2. This would be 3 plus 2 plus 3 plus 2 plus 3. Right, so 3 plus 2 plus 3 plus 2 plus 3. Okay, now you can see this is going to have the same issue as, where did it go? It's going to have the same issue as this first one that we tried, where it's like you just have this almost telescoping pattern, which isn't good, because we want to be able to come up with a closed form. However, if I go back and try to express this in terms of multiplication now, if I say, instead of calling it 3 times 2 plus 3, sorry, 3 plus 2 plus 3 plus 2 plus 3, what if I just call it 3 times 3, because there's 1, 2, 3 threes. If I call it 3 times 3, and then I call it 2 times 2. Okay, so that's not bad. And if I go back to figure 2, then I can call it 2 times 2 plus 1 times 1. Okay. And can I extrapolate that pattern backwards again to figure 1? Well, if I did it again, it would be 1 times 1 plus 0 times 0. And that works out, right? Because 1 times 1 plus 0 times 0 is just 1. So I've got 1 times 1 plus 0 times 0. Figure 2 is 2 times 2 plus 1 times 1. Figure 3 is 3 times 3 plus 2 times 2. I can pretty much guess that I think I've got a winner here, right? Because I can pretty much guess now that figure 4 is going to be 4 times 4 plus 3 times 3. Okay. Okay. So there's figure 4. Figure 10 then. I don't think is too much of a stretch at this point, because look, the first number matches the figure number. Figure 1, 1. Figure 2, 2. Figure 3, 3. Figure 4, 4. Figure 10 is going to be 10 times 10. The second number is 1 less than your figure number, right? So figure 1, 0. Figure 2, 1. Figure 3, 2. Figure 4, 3. Figure 10, it's going to be a 9 times 9. Okay, so there's figure 10. Okay, so then figure 100 is the figure number times itself plus 1 less than the figure number times itself, right? And so then for figure n, it's going to be figure number times itself plus 1 less than the figure number times itself. Okay, and so that comes out to n squared plus, and then I've got to FOIL this one out, n squared minus n plus 1. And if we can combine our like terms there, we're going to have 2n squareds, then we're going to have negative 2n's, and then a positive 1. So there you go. That's the number of tiles in figure n, which is very interesting, right? I want to do the fourfolds for this one as well, just to show you how it's different, because this is not a linear pattern. This is a quadratic pattern, and you can see that when you do the whole four folds thing. So let me just show you. Okay. So this is what we came up with, right? So now if we wanted to make a table, we could have figure number and then number of tiles. In figure 1 there was 1 tile. In figure 2 there were 5 tiles. In figure 3 there were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 tiles. And then from there we just kind of have to extrapolate what the number of tiles would be for the figure numbers, right? If our pattern is correct, right? If the pattern, well, actually, I drew this out on another page, didn't I? So for figure 4, we could still count up the number of tiles. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So it's 25 tiles on figure 4. The pattern that we came up with, by the way, so the pattern that we came up with was 2n squared, was it plus 2n? 2n squared minus 2n plus 1. So let's see if that checks out with figure 4. Right, figure 4. 4 squared is 16, and 2 times 16 is 32. So that's 32. 2 times 4 is 8. 32 minus 8 is 24. And then 24 plus 1 is 25. Sure enough, right? So the pattern works out for figure 4 as well. So that gives me some confidence that the pattern I came up with is correct. But here's what I want to point out to you, right? So getting from figure 1 to figure 2, we added 4. But getting from figure 2 to figure 3, we didn't add 4, we added 8. Right? And getting from figure 3 to figure 4, we didn't add 4 or 8, we added 12. So you can see that there's not a constant growth. There's not a constant growth. The growth is changing from figure 1 to figure 2. And the way that that shows up in the graph is that you end up with something that's not a straight line. Okay, so we can kind of plot this. Unfortunately, this grows so fast. I'm going to make kind of a big graph, I think, to try to capture the real growth here. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So there's 25. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay? And then I'm going to try to leave my axes like equally spaced down here so that you can see the growth of this thing, right? So this is 1, 2, 3, and 4. Let's plot the points. Okay? So plotting the points from our table, we have 1, 1, and then we have 2, 5, and then we have 3, 13, 1, 12, 13. Oh, it's maybe even hard to see when you do it this way because I've made the graph maybe too small or something, but 425 puts us all the way up here. But now if I had brought a ruler, you could see this maybe more clearly. Let me use a piece of paper. So using a piece of paper, you can see that the straight line that connects those first two dots isn't going to go through the other two dots. Or that the straight line that goes through the middle two dots isn't going to go through the first dot or through, right? It's not going to go through the first dot, and it's not going to go through the fourth dot either. So this is not a linear relationship. Kind of hard to see that, I guess, this way. But it's not a linear relationship. It's a quadratic relationship. Okay, you can tell that because the pattern we came up with was a quadratic pattern, right? Now, I don't expect you to do like the algebra to come up with the equation. What I do want you to know is that the graph always lines up with the equation, or rather that the equation always lines up with the pattern, right? So the equation for this graph would be y equals 2x squared minus 2x plus 1. That's really all I want you to do on this, right? You don't have to come up with the equation. Like, you don't have to try to find the vertex and do all this crazy stuff. But this would be the four folds for this particular equation. There's no slope. It doesn't make sense to talk about a slope because the slope is constantly changing, because this is not a straight line. Let me convince you maybe by showing you this relationship in Desmos. So Desmos is an online graphing calculator. Okay, so we can put in y equals 2x squared minus 2x, whoops, minus 2x plus 1. Okay, so there's this thing. So you can see that it's a parabola, right? You can see that a little bit more clearly. This is more zoomed out because it doesn't have 25, or zoomed in rather. If we zoom out so that you get 25 on there, you can see the curvature here when it's done by a computer a little bit better than when I do it by hand. But obviously it's not a straight line, right? Obviously it's not a straight line. So that's that. And what's interesting about this too is that you can see for figure 0 you would actually expect there to be, for figure 0, what's interesting, why is it saying, sorry, for figure 1, let me zoom in a little more. There you go. So you can see it a little more clearly now. But for figure 1 there was one tile. For figure 0 you would also expect there to be one tile. You can see that in the graph, but you can see it in the equation as well. If you plug in 0 for x, 2 times 0 squared is 0, minus 2 times 0 is 0, 0 plus 1 is 1. So yeah, in figure 0 you would expect one tile to be present, which is kind of interesting. So that's it as far as the full four folds are concerned, but I do want to go back to those other patterns that we wrote out for this particular pattern. Right? I want to look at the other number patterns that we came up with and see if they do in fact work. So this was one of the ones that we came up with, right? 1 times 1 minus 1 times 0, and if you can go back and like rewatch the video to try to remind yourself, wait, what was our reasoning for coming up with this? But let's see if we can extrapolate to figure 10 now. So to do that, we have to relate back to the figure numbers. So this looks like it's equal to the figure number, figure 1, 1 times 1, but this one is 3 even though it's figure 2, and this one is 5 even though it's figure 3. It looks like these numbers are going up by 2 each time. So that tells me that what I should do is maybe 2 times the figure number. But if I do 2 times the figure number, right, 2 times 1 is 2, and 2 times 2 is 4, and 2 times 3 is 6. So actually, it's 2 times the figure number minus 1. Okay? Right? 2 times 1 is 2, minus 1 is 1. 2 times 2 is 4, minus 1 is 3. 2 times 3 is 6, minus 1 is 5. 2 times 4 is 8, minus 1 is 7. So I think that's the key, is that it's going to be 2 times this minus 1, right? So 2 times 10 is 20, minus 1 is 19. So it's going to be 19 by 19 minus. And then this matches the figure number, figure number, figure number, figure number. So I think it's going to be just the figure number times, now what in the world is this? Again, this is increasing by 2. 0, 2, 4, 6. If I say 2 times the figure number, that would be 2, 4, 6. So it's offset a little bit. So I think it's actually figure number minus 1 and then times 2. Right? Right? So figure number, so 1 minus 1 would be 0, times 2 is 0. 2 minus 1 is 2, or 2 minus 1 is 1, times 2 is 2. 3 minus 1 is 2, times 2 is 4, right? 4 minus 1 is 3, times 2 is 6. So 10 minus 1 would be 9, times 2 would be 18 for figure 10. Let's see if we can do figure 100. So remember this first number, it was figure number times 2 minus 1. So 100 times 2 is 200, minus 1 is 199. And then we would subtract off, the first number was the figure number. The second number was figure number minus 1 times 2, right? So 100 minus 1 is 99, and 99 times 2 is 198. That's interesting. Oh, notice, so another way to get the pattern, notice that this number is 1 less than that number. This number is 1 less than that number. This number is 1 less than that number. Okay, so that's kind of maybe an easier way to think about it. Let's see if we can get figure n then. What figure n? Okay, so for the first number we said we were going to double the figure number and then subtract 1 and multiply that by itself. Okay? Then we were going to subtract off the figure number times this number we got by doing figure number minus 1 and then multiplying that by 2. So we got it by saying, right, figure number minus 1 times 2. We can simplify this and see if it works, right? We get 4n squared, I'm foiling this, right? 4n squared minus 2n minus 2n plus 1 minus, okay, so I'm just going to do n times, I'm going to distribute the 2 first, 2n minus 2. So I've got 4n squared minus 2n plus 1, and then I've got minus 2n squared, right, distributing that in, so minus a negative 2, so that's plus 2n. Let's combine our like terms now. 4n squared minus 2n squared is 2n squared. Okay, negative 2n minus 2n plus 2n is just going to be negative 2n, and I've got a plus 1 left over. Sure enough, right? That's the same number pattern that that we came up with before, right? 2n squared, 2n squared, 2n squared minus 2n plus 1. So there you go. This way, oh man, this way is almost impossible unless you think of it like this. So I'm going to think of it like 1 plus 4 times 0. Here I'm going to have 1 plus 4 times 1. Here I'm going to have 1 plus 4 times, this is a 4 times 1 and this is a 4 times 2, secretly, right? It's 4 times 1 and 4 times 2, plus 4 times 2. So really that would be, you could think of it like 4 plus 4 plus 4, right? 4 plus 4 plus 4. That's just going to be 4 times 3, right? And here we would have 4 plus 4 plus 4 plus 4 plus 4 plus 4. That's going to be 1, 2, 3, 4, 5, 6 4s. So this is 1 plus 4 times 6 when we get to figure 4. So I wonder if we could just extrapolate and figure out what figure 10 is. Definitely a 1 plus 4 times something, but what's the pattern? It's going like 0, 1, 3, 6. I don't know. It's like it increased by 1, and then it increased by 2, and then it increased by 3. So what is it? By the time we get to figure 10. Goodness, that's difficult. I mean, relating this back to the figure number somehow. We could try, like, figure number minus 1, figure number minus 1, but then figure number minus 1 here would be 2, and yet we're getting 3. I wonder if it's, so it's got to be something more complicated than that, obviously. Figure number minus 1 would be 3. Well, 3 times 2 is 6. I don't know. This one, I'd have to give this one more thought. I'd have to think about this a little bit more. I'm sure you could make it work, but I don't know. I think that approach was maybe not very good. This approach was a little bit better, but still not great. And I think this approach, the last one that we came up with, I think this was probably the easiest one. But anyway, so that's that. So that's all I have to say about part D. I mainly wanted to go over that just to show you like that you don't have to come up with like a perfect solution first on your first shot. Sometimes it takes a little bit of trial and error to find a way that that works for you. And so just don't give up, right? Keep pushing, keep trying to find a good solution. And then the other thing that I wanted to point out on part D is that not all growth patterns are linear. This was a quadratic growth pattern, okay? And so anyway, that's all I have to say about that. For your homework, I'm going to have you finish investigation 18. So you have part E, and I think it goes E, F, G. It goes all the way up to part H on the second page, right? So I want you to finish investigation 18. So you're going to do parts E, and then F, G, and H on the next page. Okay, and you can see the patterns get pretty interesting. So, so that's that.